A new rule in Europe says AI-generated content must start revealing where it came from. But there is an immediate problem. The internet is extremely good at destroying labels. A file gets compressed, downloaded, screenshotted, cropped, translated, or reposted through 3 different apps. By the time it reaches you, the original disclosure may be gone. So the real question is not whether Europe can make responsible companies label AI content. It can. The harder question is whether those labels can survive contact with the internet. On August 2nd, 2026, transparency obligations under Article 50 of the EU AI Act began applying. This did not create one giant rule saying every use of AI needs a bright warning sticker. The actual system is more specific and more interesting. It divides responsibility between the companies providing AI systems and the people or organizations deploying them. Providers of systems that generate synthetic text, images, audio, or video must make their outputs detectable as artificially generated or manipulated. The marking must be machine-readable and, as far as technically feasible, effective, interoperable, robust, and reliable. Deployers face a different duty. If they publish an AI-generated deepfake, they generally need to disclose that artificial manipulation. They must also disclose certain AI-generated text published to inform the public about matters of public interest when there was no meaningful human review or editorial responsibility. There are exceptions. Standard editing that does not substantially change the meaning of the input is treated differently. Public interest text can fall outside the disclosure requirement when a person or organization genuinely reviews it and accepts editorial responsibility. Artistic, fictional, and satirical works can use disclosures that do not ruin the experience. The rules also cover situations beyond content. People should be informed when they are interacting directly with certain AI systems and when they are exposed to emotion recognition or biometric categorization tools. One important timing detail is easy to miss. Systems already placed on the market before August 2nd received a limited transition for the machine-readable marking obligation. Their deadline is December 2nd, 2026. Content created before August 2nd does not suddenly need to be labeled retroactively. What changed then is the status of AI identification. It is no longer just a voluntary feature that a platform can quietly remove. For covered companies operating in Europe, it is now a compliance issue. But the word label can be misleading because there are really 2 layers. The first layer is visible. It might say AI generated, AI modified, or contain an icon that opens more information. This is meant for humans. The EU has even released optional icons for fully generated and partially modified content. The second layer is invisible. It is meant for software. Think of the visible label as the sticker on a package. The machine-readable layer is closer to the barcode and shipping history. A person may never notice it, but a platform, verification service, or regulator can inspect it. If you enjoy explanations that get underneath the headline and show how the technology actually works, subscribe, because the invisible layer is where this story becomes much more than a warning badge. There are 3 main technical approaches you need to understand: metadata, watermarks, and provenance credentials. Metadata is information stored alongside a file. A photograph may contain details about the camera, editing software, dimensions, or creation time. An AI system can add a record saying the file was generated or manipulated by AI. This is useful because metadata can carry detailed information without changing the picture, video, or audio itself. It can identify the tool involved and describe what happened. But ordinary metadata is fragile. Many social platforms remove it. Messaging apps may rebuild the file. Exporting into another format can leave it behind. A screenshot creates a new image containing the visible pixels, but not necessarily the data attached to the original file. That is why provenance systems such as C2PA Content Credentials add cryptography. A content credential can record claims about where a file came from, what tools edited it, and whether generative AI was used. The credential is linked to the media using a cryptographic hash and protected with a digital signature. A hash is like a mathematical fingerprint of the file. Change the file, and the fingerprint changes. The signature lets verification software check who attached the information and whether it was altered afterward. This makes the history tamper-evident, not tamper-proof. Someone can still remove the credential. What they should not be able to do easily is secretly edit a signed file while keeping the original credential looking valid. Content credentials can also be stored externally. A watermark or perceptual fingerprint can help a verification service reconnect a stripped file with provenance records held elsewhere. C2PA calls this idea durable credentials. Then there are invisible watermarks. Instead of attaching information beside the content, a watermark hides a detectable pattern inside the content itself. For images, the pattern can be distributed through the pixels. For audio, it can be encoded into parts of the signal that people are unlikely to notice. For video, marks can be spread across frames. Text watermarking works differently. A language model normally chooses each next token from several plausible options. A watermarking system can gently favor certain choices according to a secret statistical pattern. The result still reads normally, but a detector can examine a long passage and look for that pattern. These approaches can survive more abuse than basic metadata. Google says its SynthID watermarks are designed to withstand common changes, such as lossy compression, cropping, filters, speed changes, and some text editing. Designed to withstand does not mean impossible to remove. Every watermark faces a trade-off. Make the signal stronger, and it may damage the content or become noticeable. Make it subtle, and heavy editing may erase it. A small crop or mild compression might leave enough signal for detection. Aggressive cropping, repeated compression, re-recording, noise, or deliberate attacks may not. Text is especially difficult. A long AI-written passage may carry a useful statistical signal. Rewrite it thoroughly, translate it, or reduce it to 2 sentences, and the detector may lose confidence. Short, factual answers also give the model fewer harmless word choices in which to hide a pattern. This explains why a serious provenance system needs layers. Metadata carries rich details. Cryptographic signatures reveal tampering. Watermarks may survive when metadata disappears. Fingerprints and external records can reconnect transformed copies with an earlier version. Yet even a layered system runs into the basic mechanics of sharing online. Imagine an AI-generated image with signed provenance metadata and an invisible watermark. Someone uploads it to a platform. The platform compresses it but preserves the credential. So far, good. A second user takes a screenshot. The attached metadata is now gone, although a robust watermark might remain. A third user crops the image, adds text, and exports it again. Another account turns that image into a video. Someone else films the video playing on a phone. At every step, the signal gets weaker, and the chain of custody gets messier. A visible label has the same problem. It can be cropped away. If the label is only a platform interface overlay, downloading the file may remove it. If it is burned directly into the media, it travels better, but it can still be covered or edited. There is also a larger loophole. The rules can pressure compliant providers to mark their outputs. They cannot make every model in the world cooperate. A motivated actor may use an unmarked system, modify an open model, or deliberately remove disclosures. That leads to the most important misunderstanding about the EU rules. No label does not mean no AI. A missing marker could mean the content is human-made. It could also mean the marker was lost, stripped, never added, or generated outside a compliant system. Detection should not become a magical test where marked means fake and unmarked means real. The reverse is also true. A valid content credential does not prove that a claim inside the media is factually correct. It can help prove that a particular tool or publisher signed the file and that the recorded history was not secretly changed. A real photograph can still be misleading. A fully synthetic illustration can still communicate something accurate. Provenance answers questions about origin and editing. Fact-checking answers questions about truth. So, can enforcement turn this imperfect technology into a global internet standard? Possibly, but not because Europe has invented an indestructible label. The EU's real leverage comes from market access. By the end of July 2026, about 190 organizations had signed the voluntary Code of Practice that offers a more predictable route toward compliance. The list included companies such as Google, Meta, Microsoft, Anthropic, Mistral, OpenAI, and SynthID. These companies could theoretically maintain one transparency system for Europe and another for everybody else. In practice, globally consistent infrastructure may be cheaper. If major generators mark outputs, editing software preserves those marks, and large platforms display them, the result could spread well beyond EU borders. That is the optimistic path. Provenance becomes a normal part of the media pipeline, like browser security certificates. Most people do not inspect the underlying cryptography, but software checks it automatically and warns when something is broken or missing. The pessimistic path is label fragmentation. Different generators use incompatible watermarks. Platforms remove each other's metadata. Users become numb to vague AI warnings. Bad actors continue distributing unmarked media, while responsible creators carry the visible labels. The difference will come down to interoperability and preservation. A mark that exists only inside one company's detector is less useful than a mark that many platforms can recognize. A credential that disappears during an ordinary upload cannot become infrastructure. Europe has therefore forced the right technical question into the open. Not simply was AI used. The deeper question is whether digital media can carry a verifiable history through creation, editing, and distribution. The labels will sometimes disappear. The goal is to build enough overlapping evidence that one screenshot or one compression step does not erase the entire story. That will not solve deception on the internet, but it could make digital content slightly less anonymous about how it came to exist. Do you think AI labels will become normal internet infrastructure, or will people learn to remove and ignore them? Share your view in the comments, and tell me what technology you want explained next.